Here we are again at Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I am your host from Leviton Network Solutions, Roy Chamberlain. After completing the special edition panel discussion in our last episode, we sit down with Peter Helfrich, my colleague and fellow specification engineer here at Leviton Network Solutions. We jump right back in, steering our focus to go deeper into the structured cabling design and implementation for AI data centers. So Peter, tell us a little bit about your role in the industry at Leviton Network Solutions.
So I'm fortunate to be part of the specification engineering group, as you are, Roy. We are technical and business experience folks who support consultants, engineers, and users in helping them understand our product set, technologies, and to help our salespeople deliver those messages. My particular role has been to focus on international opportunities in business and clients that are doing work overseas to help interpret the specifications, standards, and product choices that are different, outside the United States if you're doing a project in Europe, the Middle East, Asia, wherever it might be.
Good.
It's been an exciting 12 years here with Leviton. I find it challenging but enjoyable doing what we do, helping to deliver the message and understand technologies and help other people with their designs and coming up with solutions.
Yeah, being on the spec team is definitely, it's a roller coaster, right? You have all kinds of different questions and requirements that come through. It definitely keeps it exciting. So now, a little off topic, but are you a New York Yankees fan?
Oh, no. Let's go Mets.
Let's go Mets. Huh. Have you been a lifelong Mets fan?
Yeah, when I was 12 years old was the magical season in New York, 69-70, when the Mets, the Jets, and the Knicks all won the world championship. And as a kid, that was very exciting. So I got hooked on those three teams as a New Yorker. We have two of every team, so you get to pick one side or the other, but you can't be both. That's
right. Right. Yeah, I was just curious on that. So back to our topic of AI data centers, right? That's what this podcast series is focused on. What is your knowledge and experience when it comes to AI data centers? I mean, in data centers in general.
Well, data centers in general, I've been selling into designing, supplying, building infrastructure for data centers. So infrastructure is the cabling, but even in my previous business before Leviton, that include racks and cabinets and cable trays and PDUs, UPSs, everything but the active, switching and servers. So it's been something for a few decades that I've been involved with. But more recently with the AI data centers with Leviton, I don't think anybody's got more than 5 years experience doing AI because it's such a new technology. And some of the global accounts that I support with Leviton are now developing and building AI. Some of them are the leaders in that industry, as a matter of fact. And so I've gotten exposed to what these data centers look like, how they're a little bit maybe different from your typical corporate or even hyperscale type data center. And so my experience has come through working with those clients and with our product people and applications engineering folks to develop solutions to support that AI infrastructure.
Yeah, good. So in your experience, what differentiates an AI data center from other data centers? What's unique about them?
I think what's different is the amount of cabling that's involved. I do a presentation where I found a quote and a picture of Elon Musk in one of his large AI builds at either Tesla or X, I'm not sure, where he talks about the cabling and how it's mimicking the neural network in your brain, and all of the connective tissue that ties the neurons together is cabling. And as he says, it's so much cabling.
Yeah.
So in order to build one of these networks, these neural networks or AI clusters, there's a lot of mesh cabling going on. It's not just one fabric, they'll call it, as a network, where
Yeah.
typically in IT data center, a server like a 1U server would have two network interfaces, redundant, A and B, and then a management interface of some sort to control it. And that was basically it. And those were the two networks, the management network, a computing network, and maybe there was a storage area network as well.
Yeah.
But with the AI, there can be like 4 or 6 different networks overlaid on top of each other. And the compute network is meshed, as is the storage network. The management network, there's 2 different types of management networks, many times a high speed and an out of band management. So it gets more complicated in not only the number of cables that are involved to build these mesh clusters, but that they have different purposes.
Yeah.
So, a server now, in one of these nodes, as they call them, could have, 10 or more connections for each server in a rack. So it's just the volume and the different fabrics. Also, some of the equipment, the switches that support the fabric. So where you're running these cables to isn't always the end of the row rack. Sometimes the management, just because of port densities, are differently located than where the compute fabric or the storage fabric. So you have to take that into consideration. So it can be, a little bit more complex in terms of the amount and the types and the direction that you're running cables.
Yeah. I mean, I find when I look at designs for AI data centers, it's a little harder for me to comprehend some of the numbers that start to multiply, right?
Yeah.
Compared to a standard data center.
Yeah.
Um, Now, can you implement NVIDIA or other AI equipment into an existing data center structured cabling plant?
Probably not. There's some cabling within, it's called a legacy data center, that could be reused. If you have trunks, with MPO connectors, they could be pulled out and then redeployed in a different routing, possibly. But the density and the network design is different.
Okay.
So when we see people repurpose white space, we'll call it a data hall,
Hmm.
to go from, a simpler, I'll call it, IT data center infrastructure to AI, they would typically rip out and replace.
Okay.
Maybe not the air conditioning, maybe, not the PDU distribution network, but the layout of all of the cabling and distribution parts would be redone. The other piece of that puzzle is the power densities with the AI are significantly higher. So if a data hall that was used previously is 20 megawatts or something like that with a lot of space, you might use up that 20 megawatts and only fill the room halfway, a third of the way, with AI. So you would end up
Yeah.
with a lot of empty space simply because there's not enough power, there's not enough cooling, given the new densities, the per rack power consumption, 30 or 40 kW per rack versus, 5 or 7.
Right. Yeah. So who are the big players today in the AI market? Do you know some of the differences between those players or?
Well, when you look at the players, there's different categories of the players. So the
Okay.
AI revolution, we'll call it, is the repurposing or redesign of GPUs, graphical processing units, in servers, and how a graphics card that we would have thought about years ago from the likes of NVIDIA for gaming and kind of three-dimensional immersion into war game type things, taking that silicon processing methodology and chipset and applying it to analyzing large amounts of data is something unique. And NVIDIA has had a jump up on that since they were the leader in gaming and ported over some years ago into AI. And they still own 85%, something like that, of the GPU market, the actual graphics processing unit module that is the building block. There are other vendors now, AMD and Intel, who are chasing them with new GPU modules, but they're still the big player in that way. But then those modules go into servers, and then it's the typical names that you know in server buildups, including NVIDIA. They also not only make the GPUs, but the servers to house them. But HP, Dell, Supermicro, those are the big players, some others. Then the switching gears, NVIDIA, Arista, Cisco. But then the big applications level developers that are building these data centers and running applications, AWS, Azure, Meta, Tesla, Microsoft, Oracle, the big hyperscalers are jumping into providing AI services.
Right. That we see every day, right?
Yeah.
In all the applications we use. So with all these differences in the kind of exponential growth within that space, what we might call a node or nodes, what are some of the biggest challenges that you're encountering when you're involved in designing the physical cabling infrastructure for these?
I think that the getting all the information we need from all the stakeholders is key. Sometimes it's difficult. They think of it, the networking people and the software and applications development folks think of it differently. They don't think about the physical connectivity. And so when we get information, documentation, and say, okay, we need the cabling to support this, and then we look at what we were given, it's not complete enough, or it's in a different format than what we need to fully understand how to overlay the cabling. So there's a lot of give and take with the client of probing questions that they might feel, well, why are you asking me that? Because they don't come at it from a physical connectivity perspective. So that's one challenge. And then once we have all that data, just the time it takes to sort through it and kind of draw it up in your own head, or as I like to diagram things on schematics, and then think about what's the best approach. Are we going to use trunks or discrete cables? And how to best use it. We need to know, too, we have the usual thing, well, it's 400G connections. Well, there's about 6 different types of 400G connections that use DACs, that use AOCs, that use single mode, they use multi-mode, they use 8-fiber, parallel optics, duplex LC. Which 400G are you using? Because I can't match up the cabling if I don't know that.
Right.
Also, some of the time frames that these folks are working under, these are very, very expensive builds, multi-millions, tens of millions, hundreds of millions of dollars of gear. And when investment people put that kind of money up front, they need to see returns as soon as possible. So the pressure is on to build these and deliver these in rapid time. And we sometimes get caught. We need time to sort through it and put together a design and a bill of material, and then it has to go through all of the purchasing processes and then production and shipments and things like that. So it's a pressure cooker at times.
Yeah, so thinking along those lines, once the design is complete and you're kind of moving forward with installation, who's at the site putting these things together? Are they the same kind of people that would be in a standard structured cabling installation? I mean, are there different players involved than what you normally see?
Yeah, I think in the data center world and in the hyperscale environment in particular, very large data centers, and now with the AI, there are specialty contractors that work in these environments and have the experience in data center, which is a little different than doing cabling in an office building or a college campus or a hospital. Each one of those, not that anyone is more important than the other, but it's a little bit different skill set. Much of the cabling in data centers, particularly AI, is all pre-terminated with MPO connectors and cassettes and adapters, and the ability to handle those and cleaning of them and how to test parallel optics, things like that are unique. And the staging, building pods in succession, how to stage your purchasing, how to stage your deliveries, how to stage your manpower to move in a logical fashion through a data center, pod after pod, and handle that. So it's a skill set that's learned, and there are specialty contractors that are good at it.
Good. That's definitely insightful there. So, for a structured cabling contractor or somebody who specializes in these, what do they see for design documents and information to allow them to kind of do their portion of the project?
Well, they would usually get a package. It would start with the floor plan of the data hall, how many rows of racks and which ones are server racks, which ones are network racks, which ones are, meet me room. So they'd have a physical layout, then the cabling design, the schematics that go with it. What is the cabling coming out of each server rack? Where is it going? Is it end of row, middle of row? And there would be different networks or fabrics. So here's the cabling for the compute fabric in one set of documents. Here's the cabling for the storage. Here's one for in-band management. Here's one for out-of-band management. And there should be enough detail there for them to pick through that. Now, they may be provided with a manufacturer's bill of materials as part of the bid package, or it may be on them to work with the manufacturers to develop the bill of materials. That's the package they would get.
Okay.
And again, they're in the same boat that the designer is. You have to sort through all of those different packages and piece it together and come up with a plan, and then figure out your labor, how you're going to approach the job and what material comes first and how do I deploy.
Yeah. Yeah. Especially logistically, right? With all the different aspects there.
Yeah.
So, as a new technology, I know you have worked with some companies, clients, where you've done, more than one. You've done a few different implementations and designs. Are there some lessons learned in the industry from the initial projects that were coming on board, let's say, at the beginning when you started working this, to what we're pushing to install and how to organize the structured cabling today?
Yeah, I think one of the things that struck me early on is that the infrastructure was a lot of direct connect cabling. So literally a whole bunch, thousands of patch cords and array cords going point to point from this port on this piece of equipment to that port 3 rows over on that piece of equipment, and never went through a patch panel of any kind. And there seemed to be some confusion in the industry. Why would you do that given the density of cabling? Doesn't it make sense, certainly, let's say, at the end of the row, to organize all this incoming cabling onto a patch panel and then patch it into the switch ports? And there was thoughts in the industry that if you added patching points, you were adding latency, and latency is the enemy in an AI hyper scale or a high performance computing environment.
Mm-hmm.
And I think you and I, been around. Latency is just how far the signal has to travel along the fiber optic cable. The further you go, the more time it takes. So we're talking nanoseconds. But if you pass through a patching point, you're adding some insertion loss. So the signal strength degrades a bit. And as long as you stay within the loss budget end to end, you're fine. But it shouldn't slow down the speed of light.
Right.
So I think people have gotten around that now, particularly when we're not talking about in the laboratory and developing these systems and just a whole bunch of cables and let's connect it together and see how fast we can make it go. Now, when we're building them for production purposes and in large scale networks and build sites, we need to kind of control and manage the cabling and organize it a little bit better. So that was something that I've learned to understand where they're coming from, but guide into there's certain aspects that we should add some structured cabling to it.
Yeah, and that must help in the pathways as well. Instead of having all the individual array cords and patch cords going the whole distance, right? You can consolidate them into jacketed cabling and stuff like that.
Yeah.
As you're working with these products, obviously the product managers for a company like Leviton Network Solutions, right? They're supremely involved, right? They have to have the products available, right? For us to be able to put them into design. How do the product managers support you, and how are they contributing to the AI data center industry and our clients?
Well, because it's different than previous builds of data center, they're very eager to see what the clients are doing. And as part of the spec team, which is customer facing, we see it first, and oftentimes anyway. And then so we share that information and look for guidance and say, look, they're trying to do this. I don't see it in our portfolio. Can we do it? Oftentimes there's things in development that we on the front lines aren't aware of, and then we'll collaborate with product management. We say, oh yeah, we do that. We've been working on it in the lab, but we can definitely, do it that way. And they want to know so that we can develop new products. So there is a lot of interaction between frontline specification sales engineers like us and the product management people behind us to understand these new technologies and look for gaps in the product line, develop new products, help solve problems for customers, and customize.
Yeah, that makes sense. It's definitely a little more of a team, right? We're adding people to the team, it seems like, right?
Yeah.
In general, all across the board, a little bit more specialized, requires more collaboration because of how important and how intricate these spaces are. So for people who are interested, we've kind of gone through the whole process here. People who are interested or are looking to understand more, acquire resources to see design architectures and products for data center and AI data center. What does Network Solutions at Leviton have available? How do we access that information if I'm just a contractor or a designer?
Our website is very strong when it comes to background information, not just product information. You can see links to webinars that we've given. Also, if you're active on Leviton and have registered, you'll get invitations to live webinars where we present a lot of detailed technical information, not just about our product set, but different technologies like AI. There are easy learned webinars that are stored on the system that you can log in and at your leisure watch, either a recorded webinar or just other topics that we've presented over time that are very helpful. Those are all usually have a companion white paper that goes with it. So if you'd rather read through this information, those are available for download. And always reach out to your local reps, and they can bring experts to you either in person or virtual to do lunch and learn type discussions, to just listen to what your challenges are and come back with solution sets and ideas. Sometimes we help clients through problems that aren't really even Leviton product related, but we have a whole host of people with lots of industry experience that help our customers with their designs and their challenges. So there's plenty of information on the web, downloadable, watchable, in-person support, remote telecommunications support available from Leviton.
Yeah, great. Well, Peter, you're a wealth of knowledge. It's been great going through these questions with you. Thank you for joining us.
Take care.
Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth, or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.